Hey, good morning. This week we will be discussing related rates. We're going to look at a few different shapes, but we're going to start out with the most straightforward one, which are rectangles. So I've made some new notes for you. These are not in your packets because we didn't do that shape in your packets. Instead, I'm going to upload a PDF to Google Classroom. You can print it out or you can mark up the PDF. It's completely your choice. But here are our steps. We're going to make a diagram. Name the variables and constants. We're going to identify the rates of change that are given and the ones to be given, the ones we need to find. We're going to write an equation that relates the variable whose rate to be determined to the variables whose rate of change is known. We'll differentiate with respect to time and solve for the unknown rate of change. I know that seems like a lot of instructions, but one step at a time and it will be okay. So example 1, area. A rectangle has a length of 4 inches and a width of 3 inches whose sides are changing. The length is increasing by 5 inches per minute and the width is shrinking at 7 inches per minute. What is the rate of change of the area? So the first thing we need to do is draw a diagram. So there's my diagram. Let's label L and W. I always start these out with what we know and what we need to find. We know that the rate of change of the, let's find this, length is increasing. And that's going to be our dl dt is 5 inches per minute. And the width, dw dt, is shrinking at 7 inches per minute. Now because it's shrinking, we'll call that negative. We want to find the rate of change of the area. That's going to be dA dt. And I'll tell you that exact moment that wants to happen. We want to find that when the length equals 4 and the width equals 3. So what is the area for a rectangle? You guys all know that the area formula is length times width. I'm going to zoom in here so I can see a little bit more. We need to find the derivative of this. dA dt is going to be the derivative of length times width, but we have length and width, so that's a product rule. So it's the first times the derivative of the second. The derivative of w is going to be dw dt. And then the second, which is w, times the derivative of the first, which is dl dt. So dA dt we have over here on their own. L, we know from over here is 4. dw dt we also know is given is -7. W is given up here, down here, which is 3. And dl dt is also given, that's 5. And then you can use your calculator and just figure out what this is. So dA dt is 4 times -7, which is -28, plus 15. The rate of change of the area is going to be -13. And just double check my units here. I believe it's inches. Yes, it is. Inches squared per minute. There you go. There's your solution. So what we're going to do is just try to keep similar shapes together. So I have another area problem for you. A rectangle has a length of 10 inches and a width of 3 inches whose sides are changing. The length is decreasing by 2 inches per second and the width is shrinking at 1 inch per second. What is the rate of change of area? So again, same idea. Just going to grab a different color pencil. Draw yourself a diagram where you have length and width. Now I leave them as variables because they're always changing. Don't put the numbers in yet. Don't put in the 10 and the 3. We know specific rates. We know dl dt is decreasing, so it's negative, by 2 inches per second. And we know the width is shrinking, so it's dw dt at -1 inches per second. Again, we want to find the rate of change of the area. So this one's just like that last one, dA dt. We want to find that, and that vertical line means the word when. This means when. The length is 10, and the width is 3. So, area formula for rectangle. Area is length times width. We have to find the derivative with respect to t, so the rate of change of the area with respect to t. L and W are being multiplied, so that's product rule. So L, the derivative of W is 1 dW dt, plus the second, which is W, times the derivative of the first, which is dL dt. And then you just put in the values that you know. The length was 10. dW dt is given as -1. The width is 3. dL dt is given as -2. So dA dt is -10. The second piece over here, 3 times -2 is -6. So the rate of change of the area is -16 inches squared per second. Not bad. All right, so that's 2 examples on area. You'll have other homework problems that deal just with area. Then we're going to try perimeter. Same idea. We're still dealing with rectangles. A rectangle has a length of 12 inches and a width of 6 inches. Whose sides are changing. The length is increasing by 7 inches per second and the width is growing at 3 inches per second. What is the rate of change of the perimeter? So again, draw yourself a model. Get in the habit of doing that now because the models get a little bit more complicated later on. Zoom in over here. What do we know? We know that dL dt is 7 inches per second. That's right here. We know dW dt is 3 inches per second. And that's right here. And we need to find, this time it's not area. This time we're looking for perimeter, dP dt. When is that exact moment that we want to do that? When the length is 12 and the width is 6. I can see those peeking out right here. There's the 12, there's the 6. So what do we do? Well, you need your perimeter equation. The perimeter of a rectangle is 2L plus 2W. So we found the derivative. This one might even be easier than the last. The rate of change of the perimeter is 2. Derivative of length is dL dt. The derivative of the width is dW dt. So the rate of change of the perimeter is 2 times dL dt, that's given, that's 7, plus 2 times dW dt, that's 3. So the rate of change of the perimeter is 14 plus 6. So that is 20 inches per second, not inches squared. Area is inches squared, perimeter is just inches. So there's our solution on that one. I'm going to need to do one more perimeter problem with you, and then we're going to do homework for this one a little bit different. It's not a worksheet. It's not in your textbook. There's a website out there that I really like. I'm going to have you guys try that. I will post in Google Classroom how to log on to that website. So example 4, perimeter. Here's our rectangle, a length of 12 and the width of 9. What do we know? We know the length is increasing, dL dt, at 2 inches per second. And the width is growing at 9 inches per second. Again, we want to find the rate of change of the perimeter, which is dP dt. When do we want to do that? When the length is 12 and the width is 9. So perimeter formula. Perimeter is, twice the length plus twice the width. Find the derivative with respect to time. So it's 2 dl dt plus 2 dw dt. This is really just like implicit differentiation with respect to time. That's what we're adding on the end. Oh, I forgot dp dt. You got to take the derivative of both sides. And so the rate of change in the perimeter is twice. dl dt is 2. dw dt is 9. So this is 4 plus 18, which is 22 inches per second. All right. Again, our homework assignment is going to be on a website for this. It's called Delta Math.